Unit 8 time. This is gonna be great. All right, so to learn about function notation, domain and range, which are the topics of today, I want you to let's go to your imagination. There we go, get those twinkle sounds. We're gonna go to the grocery store with the algebros. So you get in the grocery store, all the algebros buy product. Mr. Kelly loves the peanut butter. He noticed there's a sign on it, it's $4. Okay? Mr. Brust loves the Mountain Dew, probably because he has a mountain of work due, but he noticed that cost $1. All right, which algebra is which now? This is not going to be difficult. Mr. Bean loves beans. They also cost $1. Now, notice as we're doing this, we're walking through the aisles, we're picking out our products. There's a sign on each one. So I know that if I put the peanut butter on the belt, bleep, bleeps up, $4. I know that the Mountain Dew and the pork and beans will bleep up, bleep, bleep, $1. Now, is it okay if both of these cost the same amount? And yeah, that's okay. And especially if you go to like a dollar store, everything costs $1. So everything would point to the dollar. What happens? Well, we got to do this last. What is this? This is Sully's. What? Rogaine. What is that? Oh my goodness. All right, so Sully's Rogaine. This is what Sully gets. That's going to cost $22. That's expensive. All right, so we've mapped all of the items over here. These items that are mapped, that's called the domain. So we're going to write that out. That's the domain. And the prices in this example are called the range. Now, as I said before, is it okay if 2 of the domain gets mapped to 1 in the range? Yeah, that's okay. That's okay. But what happens if I have one product and it gets mapped to 2 different prices? That doesn't happen in a grocery store. That doesn't happen in the commissary. You can't have, I got to erase that. You can't have 2 prices for one product. And I'm not talking about a similar product. Maybe it's bigger, or I'm talking about the exact same thing having 2 prices. That wouldn't work. Okay, people would go into the store and they'd get confused and ringing them up, and people wouldn't know how much to pay. So this whole pricing scheme where we map from one of the elements in the domain to one of the elements in the range, that is called a function. Okay, a function is where you map to one and only one on the right in the range. As I said, it's okay if 2 items are mapped to 1 price, but you can't have 2 prices on 1 item. So going through the notes, a function is a relation in which each element of x is mapped to only one element of the y, and only one. All right? The set of x is called the domain, and the values in y that get mapped are called the range. Sometimes we use different words like input. Okay, the input up here would be these values, and the output would be the range. Maybe we write those down. Input, we'll put them in parentheses, because sometimes we see those words, input and output. And think of a machine, like the thing that bleeps up your, what's that called? A price scanner. So when it bleeps, you get 1 price out. You never get 2. All right, so how are we going to use notation? Well, here's what it looks like. If I have a capital F, that stands for function notation, and we're going to use parentheses to show what the input is. So in this example, they're saying, what does the function map peanut butter to? So peanut butter is the input. It gets mapped to $4. All right, what does the function map beans to? Beans get mapped to $1. All right, now working backwards. The function mapped some unknown value to 1. All right, so this is like the y value. And this value, and here's the x value. So what happens if y is equal to 1? We need to work backwards and find x. Let's look at our mapping here. So if y is 1, that's right here. We need to work backwards and see what products. In this case, there are 2 products. We have Mountain Dew, and we also had beans. Both of them get mapped. So sometimes you have 2 x values. All right, pause the video and try the next 2. All by yourself. Go. Okay, so hopefully you got these 2 answers. This one is kind of working backwards from the other example we did there. If f of a equals 4, that means I plugged a in, and my answer was 4. It means the price was 4. So what was 4? The peanut butter. And then for the second example, f of w, All right, so, I plugged a W in and I got 12. Well, I go up here, nothing is 12. Well, because nothing's 12, we say there's no solution there. Easy enough, right? All right, let's do some examples right here. Are the following functions? So think of the first column as like the products in the store. In the second column are the prices. Now here, we have 3 going, if you want, let's write it out. We have 3 going to 5. We have 4 going to 5. We have 2 going to 7. And we have a 5 going to 2. If you walked into a store and these products and these prices existed, is that a valid pricing function? Is that a function that can work? Yeah, it sure is. So this is a function. Booyah. What is f of 5 equal to? F of 5 will equal 2. When I plug a 5 in, I get 2. Solve for x, which means work backwards, if f of x is 5. So if the price is 5, what was the value of x? If the price was 5, then x equaled 3 or x equaled 4. The domain are all of the products, all the values of the x. Let's write that down. That's x, and that's generally what our y is. So the domain would be 2, 3, 4, and 5. And what would the range be? All of the y values to get mapped to, so that would be 2, 5, and 7. I don't need to write the 5 twice. And if you notice, I like to kind of write it in order. It kind of keeps it straight for me. You know what I'm saying? That way I know the lowest value, I know the highest value, but the order is really not important. Okay? So the first one, are the following correspondences functions? Are they a function? If so, give the domain and range. If not, explain why. So what do we look here? I'm going to draw a little mapping. Let's do this. We get 2. I'm going to draw a mapping diagram just so I can look at it. 3 goes to 5. I'm going to put a 5 over here. And 4 goes to 5. And 2 goes to 7. Let me pull a 7 up there. And 5 goes to 2. All right, so as I said, think of the commissary. These are our items. They all have one unique price. That's okay. So yes, this is a function. We're going to write that down. Yes, that's a function. F of 5 means I want to plug 5 into this function. I'm going to look for where 5 goes. 5 goes to a 2. So F of 5 is 2. And now solve for x. It's like working backwards. Remember, the first thing's x. The second one is y. Solve for x if f of x, which is like y, if f of x is 5. So what are the x values? Well, you notice here we have 2 x values, 3 and 4. So I'm going to say x can be 3 or x can be 4 when f of x is 5. It's this one and it's this one here. F of x is 5. Okay, now the domain, all of the x values, the first values. So I'm going to say the set of 2, 3, 4, and 5. In the range are all the y values. So I'm going to say the set of 2, 5, and 7. And those are all the y values. Done with that one. Number 2. Is this a function? So we have 2 going. So I'm going to write it out. So 2 is going to -1. And then -1 is going to 3. And then 2, I already have a 2. 2 is going to 6. I think you see the problem that's showing up here. And then 4 is going to 2. Well, look. We have 2 going to -1 and 2 going to 6. So in my analogy, this is like going to the commissary or the grocery store. You have item 2 with 2 different prices. So f of 2 here, well, it would equal -1 and it would equal 6. But because there's 2 answers, this is not a function. Not a function. All right, but if we were to solve it when f of x equals 2, then we would get a 4 for x. Because look, f of x is 2. So the answer is 2. We work backwards. X must have been 4. The domain here, we have -1, 2, and 4. And the range is, what do we get here? Well, we got one of everything. So we got -1, 3, 2, and 6. All right, that's our range. Do they have to be in order? Well, they don't have to be, but I mean, you know. Domain and range. Just remember, the domain are the x values, or the first, and the range, they are the y values, or remember that we can use f of x, which is another way to write the y values. All right, let's keep going. Number 3, f of -2. All right, so f of -2 equals 0. Solve for x if f of x equals 5. So this is f of x over here. This is like the y. So if it equals 5, I don't see any value that equals 5. So I'm going to write no solution there. We don't have any x value that equals 5 when you plug it in. The domain, 0. So we get 0, -2, 11, 14. And the range, we only have two values there, 0 and 3. Perfect. Next example, f of -2 here. So I'm looking at -2, it goes to -5. Solve for x if f of x is -27. So f of x is -27. Once again, we have no value here. This is also no solution. Okay, I put two of those in there so that you really get it. Now up here, look, most of the time there's a solution. Okay, but sometimes there isn't. So solve for x if f of x is -27. There's no solution there. Okay, what else we got here? Domain. Now the domain, I'm only going to use the values that get used. So -2, 12, and the range would be 3 and -5. So we're going to put those in. Easy enough? We just got to keep in mind, x is on the left, y is on the right. What happens when we don't have a picture, though? Well, we have an equation. So remember, this is where the x value is. This is the part that students mess up. If the x, normally we have f of x. This is saying that x equals -2. Notice how that's different than solve for x. So we don't know. So here, x equals, I don't know. So we're going to have to solve for it. The whole function equals 101. So that is like where the y value is. Here, we don't know what the y value is. So we're going to solve for it. So the way these work with the equations, if you get f of -2, we're going to write it out. F of -2 equals -2 squared plus 1. So notice I just plugged it in where the x's are. This equals 4 plus 1, which is 5. So I'm going to write f of -2 equals 5. Done with that. Now solve for x if f of x is -1. So I need to plug a 101 into this equation here. So 101 is going to equal, right? Because that's the answer I get. So I put it here where the f of x is. I don't know the x value, so I'm not going to sub in for x. So 101 equals x squared plus 1. If I subtract 1 from each side, we're going to solve this equation. So we get 100 equals x squared. And then, do you remember what number squared is 100? Well, you get x equals 10. But you also remember that you could get x equals -10. There's 2. That's kind of a review back from unit 2. All right, so you get two answers when you square them, give you 100, 10 and -10. All of these problems where you have to solve it and you get a squared, I make them so that you can do it pretty much in your head. You should be able to figure that out and look at it, like what number squared is 100. So the answer to this, solve for x, is x equals 10 and x equals -10. If you want to get fancy, you could write it like this. This is the fancy way to do it. That's fancy, plus or minus 10. All right, last one here. Number 6, we have f of x equals 2x plus 5. Find f of 11. So f of 11 means we are plugging in 2 times 11. That's where the x goes. And then we add 5. So f of 11 is going to equal 22 plus 5, which equals 27. Easy enough, right? Now, solve for x if f of x is 2. Remember, we don't know what x is, so I have a question mark. But we know that the y value is 2, or f of x equals 2. So I'm going to write 2 equals 2x plus 5. If I subtract 5 from each side, I get -3 equals 2x. And then when I divide by 2, x is going to equal -3 halves. That is an ugly, it's a fraction. It's okay, it's a fraction. We good. Let's do some more. Okay, so this next part is very common. They're going to define two different functions here. So we have f of x, but notice there's f of x. We also have g of x. So we have two different functions now, f and g. Yeah, they changed the f. That's okay, just same thing. So they want us to work through some values here. The first one is f of 5. So f of 5, let me write f of x. So f of x equals 3x squared plus 2. That's according to this. I just copied that over again. So f of 5 would equal 3 times 5 squared plus 2. I'm just plugging in x equals 5, so I plug a 5 in here. Well, this equals 3 times 25, because 5 squared is 25. We have to do our exponents first. Work all this out. 75 plus 2, f of 5 equals 5 squared 77. Okay? How about g of 3? Well, let me write g of x out. So g of x equals 2 to the x. So g of 3 would equal 2 to the third, which I know as not 6, that's 8. Okay, that's easy enough. So we're just plugging in. F of 5, plug into F. G of 3, plug into G. What happens when they want you to do 2? Well, look, we already did F of 5. F of 5 is 77. We figured that in part A. And G of 3 is 8, right? So 77 plus 8, that all equals 85. Easy enough. Done with that one. How about F of 2, G of 1? You'll do that one later. E, F of y plus 2. So let's write out F of x equals, oh my God, Mr. Kelly, when did you learn how to write? Today? F of x equals 3x squared plus 2. So this one's a little tricky. You have to plug in y plus 2 to x. I know, right? I know. So 3, instead of x, I'm plugging in a y plus 2 squared plus 2. Is that crazy or what? Well, you know, if you take y plus 2 and you square it, it means you got to multiply it times itself. So we have to double distribute. Oh my goodness. We get y squared plus 2y plus another 2y plus 4. Remember that? Y squared plus 4y plus 4. This goes back to unit 2. So y squared plus 4y plus 4. And that is just this part right here. We still have the plus 2 at the end. So, first question, why didn't I give you more room? Second question, when you multiply this all out, final answer is, my goodness, had to make some room. So you have to distribute the y, 3y squared plus 12y, because you distributed it, plus 12, and then you have that plus 2 hanging out at the end. But you know what you could do? Here, I promise. I'll go back and give you guys more room. But that was 12 plus 2. That just equals 14. Okay? So that is E. Right now, pause the video. Do F, G, and D. Do these by yourself. Go. Pause the video. Okay, welcome back. We're looking at D. Like you got to plug into F, a 2. You got to plug a 1 into G. These are two values you get. Hopefully you got a 16 for that one. Next question. Okay, for F, g to x equals 2 to the x. So g of the n minus 3, you just plug an n minus 3 in where the x is. Can you simplify it anymore? No, you can't. So you're done there. G, find a value of m such that g of m is 32. All right, so if g of m is 32, then 32 equals 2 to the m. Now, where did I get that from? G of x equals 2 to the x. So if I want to, they're telling you g of m. All right, so I got to change the variable to m. But g of m equals 32, so I'm just plugging a 32 in. So 2 to what power is 32? 2, 4, 8, 16. We're going 5. M equals 5 here. So that one we just got to kind of figure out in our head because we don't know how to solve those equations. But those are the answers there. All right, we only got one more type. Okay, so last one. Mr. Brust is selling Algebro t-shirts to raise money for his ankle warmers, which, by the way, he needs because his pants are so short. For each t-shirt sold, Mr. Brust takes a profit of $5. Let the function B of t, Brust's t-shirts, equals 5t. That represents the scenario. So first, describe what B of 3 means. So B of 3, we're going to describe this using words. B of 3 means what? Okay, well, notice the 3. The 3 is where the t goes. So what does the t represent in this situation? So B of t-shirt, that's what we're plugging in. This is how many t-shirts. So B of 3 means Brust sold 3 t-shirts. That's all they want for this. We're just using our words. Describe what B of t equals 20 means. So in this situation, we don't know what the t is, so we don't know t-shirts. But we do know what the other number. Now, B of t equals 5 t's, $5 per t-shirt, and that's how many what? That's the profit that he's going to make. So B of t means Brust made a profit of $20. So a little heads up. There's one of these on the mastery check. There's a question just like C. Describe what B of 12 equals 60 would mean in the context of this problem. Well, to do this, you got to be like, okay, so this number right here, that is normally the what? That's the T. So that's the number of T-shirts. So Brust sold 12 T-shirts for... And then the other number would be his profit. So a profit of $60. And that's it. And now I have a context statement. It's written in context, which means in this problem, compared to this problem right here, this problem of T-shirts and money. Okay? That's what that means. So there's one of those on the mastery check. A little heads up to you there. That's it. This is Mr. Kelly and Kaiser slaughtering. Remember, it's nice to be important, but it's more important to be nice. See